Hello, and thank you, Mark, very much for the invite. It's great to be here. So I want to talk about Ireland's changing climate, very topical issue. And there's four things I wanted to touch off today. I wanted to touch off the climate change basics. I wanted to look at then, how do we actually know our climate is changing? And also look to the future on what that holds in store for us. And also by knowing all this, how does that actually help us to make decisions now? So let's jump straight in. So we'll start with a bit of planetary physics, but I guarantee nothing you don't already know. So we know the Earth is a sphere, and the energy comes from the sun. Now, when the sun's energy reaches the equator, those rays almost impact with a direct hit. And I always think of it as a lot like kicking a football. If you kick a football in the middle of the ball, a lot of the energy goes into the ball and the ball goes forward. But if you were to kick the ball at the top of the football, it kind of skims off. Some of the energy goes into the ball and goes forward, but not as much as had you hit the middle or the equator. And this creates a temperature difference in the sense that the equator becomes warmer than the poles. And that temperature gradient is what helps drive our weather. Well, let's leave the textbooks for a few minutes and let's look at real life. This is an animate compass made from EUMETSAT. These are the European Meteorological Satellite people. And what we're looking at here, we're looking at real world images, and we're looking at how the cloud moves around our planet. Now, if we look at the equator, we see the warm air is rising at the equator, it condenses into clouds, drops all that rain, that's when we get the rainforests. Then that now dry air falls down either side into the tropics, that's where the Sahara Desert, the plains of Australia are. We can see Ireland in there as well, all the weather patterns that affect Ireland. As the wind goes around from the west, it hits the Rockies, goes up in the air and comes back down and spirals around to these low pressure systems that we're so familiar with. Also, if you look at Ireland, it's green compared to the white and snow of Canada and Russia. And again, it's because of that Gulf Stream, that warming effect that we're so familiar with. I picked this month, October 2017, because this is Hurricane Ophelia. We can see it developing out there in the Eastern Atlantic. Now, this is actually a full-blown hurricane traveling in the direction of Ireland and caused quite significant damage. And unfortunately, we lost a few lives in that. And what I'm trying to show here is, when we talk about weather, we mean the instantaneous state of the atmosphere, or effectively it's what we see when we look out the window. Is it sunny or rainy or cloudy, or is it lightning? But when we talk about climate, we mean the average of these weather conditions over a long period of time, usually about 30 years. So the climate is the typical weather we'd expect to get at a certain point on the Earth at a certain time of year. Now, I don't want to delve too much into this, but it's important that we understand the energy balance. What happened over many, many thousands of years, that energy coming from the sun created an equilibrium with the amount of energy coming into the Earth and the amount of energy going out. And I mainly just want to look what's happening on the top of the atmosphere. So that energy we saw at the start coming in from the sun, we can measure that, and it's about 340 watts per meter squared. Let's just call it 340 units. Now, some of that sun's energy comes to the Earth, gets absorbed by the Earth, some gets reflected by the clouds. A lot of the energy that's absorbed by the Earth gets re-emitted in the form of heat energy. A lot of that escapes, and some of that gets trapped by the clouds and by the gases and so forth as well. And what's happening at the top of the atmosphere is 340 units of energy is coming in, but on the way out, we have 100 plus about 239. We only have 339 going out. So we have a surplus. We have slightly more energy coming in than going out. And what that's doing is that's just adding to the warming of the planet and incrementally, slowly warming the planet. Now, how after thousands and thousands of years this equilibrium went out of sync was largely because of the introduction of additional greenhouse gases. Now, greenhouse gases are actually a good thing. I want to say that again. Greenhouse gases are actually a good thing. If it wasn't for greenhouse gases, the average temperature of the Earth would be about -18 degrees and all the fresh water would freeze. So greenhouse gases are important in the atmosphere. But over the last 200 years, adding a lot of additional greenhouse gases to the atmosphere has changed this energy balance and is increasing the amount of heat that gets trapped in the Earth. Now, how do we know our climate is changing? I want to take a look at a place very close to my heart, Valentia Observatory down in Carrickfergus, County Kerry. I want to look at our stereotypical observer. Let's call him John, our weather observer. And we've many of these across the country. And let's say John spent his entire professional career at Valentia as a weather observer. So that's 40 years. 40 years you're dedicating, working your life to making weather observations. And that would equate to about that much on the records set from Valentia, going back to before 1880. Now, John would have worked as part of a team of about 6 people, working morning, daytime, and evenings, 365 days a year, making weather observations. So, as part of a team of 6, John's actual contribution for the 40 years of his life would have been about that much data to the record set from Valentia. And when you look at it in that point of view and think of where you are in your careers now and think you're working the rest of your career to 40 years of service, all of your life's work goes into producing high quality record set. And it only covers that much from the record set from one particular station. And you get a feel for the monumental effort and dedication needed in order to piece together a reliable, accurate climate data series that can be used with climate change studies. We've got 2 graphs here. The top graph here is rainfall at Valentia, and the graph below it is rainfall on the east coast in our station in Phoenix Park. And we see about twice the amount of rain falls on the west coast as the east coast. Remember that, we'll come back to that. Now, because of the dedication of the likes of John and the many other observers in Ireland and all around the world, we're able to piece together a picture of what the temperature of the planet has looked like and how it has changed over the last 140 years or so. And what we're seeing is a consistent trend of increased warming. And there's many, many ways to represent this trend. There's climate stripes and there's climate spirals. I particularly like this one from Antti Lipponen, who works in the Finnish Met Office. And here he's broken down the warming in all different countries. And what we're looking at here, a blue bubble is colder than normal, and an orange-red bubble is warmer than normal. Ireland is over on the right-hand side there. And what we're seeing as we move through the last century or so, we're beginning to see what we see in all the other global temperature graphs, is this consistent trend towards more and more warming. So we can clearly see the warming of the planet everywhere. Now, I want to take it back to Ireland a little bit. What we're looking at here is Eireann measurements from the likes of John and others around the country over the last 120 years or so. And what each orange dot is the average temperature for that year. And if we draw a simple linear trend through it, that white line through it, we see that there's an increasing trend in temperature. So Ireland is getting warmer. So what we're seeing on the global signal, we're also seeing happening in Ireland. And what we see is the temperature has increased by about 1 degree over the last 100 years on average. Now, pop quiz. What's the average temperature in Ireland during the summer? Shout at the screen, nobody can hear you. So the answer is it kind of depends where in Ireland you are. But if you take the mean temperature, including nighttime temperatures over the summer, it's about 14 degrees. And during the winter, give or take about 5 degrees. So 14 minus 5 is about 9. So every year, Ireland passes through an average temperature change of 9 degrees without really any difficulty whatsoever. So is an increase in 1 degree really that big of a deal? Unfortunately, the answer is yes, and let me show you why. Our climate follows what we call a normal distribution. So most of the time we get in around what we expect, and sometimes we get deviations from that. So sometimes we get colder than normal or wetter than normal, but most of the time we get in around normal. Now what happens is if you move where the normal is, we start to bias the extremes. And what happens is all of our ecosystems, our civilizations, our building standards, they're all based on the type of weather we would expect to get in our region at certain times of year. But if you start changing those and shifting those extremes, you start knocking all that out of balance. Here, a colleague looked at the temperatures, all the temperatures we have in our database for February for mid-century. These are the light green dots. So it's the frequency of temperatures that we get. And if we fit a normal curve to that, it looks something along the lines of that. And what we're seeing is most of the time we get something in and around for max air temperatures in Feb, in around, what's that, about 8 degrees or so, during the 30 years between 1960 and 1990. Now, if we look at just the last 30 years, which is the navy dots, we see a normal curve like that. So this moving of the normal isn't just in theory. We're actually seeing this in the Irish record set. What we're actually seeing here was seeing that effectively spring is arriving earlier on average. Now, thankfully, there's lots of statements to keep an eye on. The WMO, the World Meteorological Organization, they're the governing body of weather and climate globally. So all Met services will conform to them. And every year they bring out the latest state of the climate report for the world. And in the latest one, they're seeing that it's an average temperature rise of 1.1 degree. Last year, we know it's record levels of carbon dioxide in the atmosphere. And after the seas are beginning to increase further, sea level is continuing to rise. And it's always important to point out that when it comes to sea level rise, it's not just melting of ice sheets that add to it. It's the thermal expansion that adds a huge proportion to the actual sea level rise itself. So bear in mind, it's global warming is the cause, but it's climate change is the consequences. Now, Ireland, we're about to launch between Eireann, the EPA, and the Marine Institute a significant state of the climate report for Ireland in the coming months. So we'll advertise that when that becomes available. Now, moving on to the future, what can we expect? Now, here we see relatively hot off the press global simulations from the EC Earth model. These are done by a colleague, Dr. Paul Nolan, out of iCheck. And what we're looking at here is we're looking at this model, which is built by the EC Earth Consortium, which Ireland are involved in through this research project funded by EPA, Eireann, and the Marine Institute. And what you do is you run the global climate model on some of the world's biggest supercomputers over the past, which is that black line we're seeing on the bottom. And we do that to make sure it agrees with observations. And then we let it continue into the future under different emission scenarios. And the scenarios we're looking at here, we're looking at what are called SSPs, or shared socioeconomic pathways. So these are slightly different to the RCPs that many people may be used to looking at. The RCPs were the emission scenarios that we used in the latest published IPCC report, the AOR5. And they're very much based on the physics. They're very much based on the radiative forcing, that energy balance that we looked at the start. The SSPs are a bit more advanced. And what they're looking at, they bring in socioeconomic aspects into it as well. So they're building in the likes of changing technologies, people's behavior, even the fragmentation of politics, the likes of Brexit and so forth, and how if global politics is more fragmented, the more difficult it is to agree and implement global agreements. And we see across all its global scenarios that we're locked into a period of warming. The question is really about how much warming are we actually locked into. And what we can see from modeling the physics over the past and over the observations is that the models have a very good grasp of actually capturing the actual physics of the atmosphere. One of the biggest uncertainties as we look into the future is really what the emission profile, what path we're actually going to follow. And an awful lot of that is dictated by policy and do we actually meet our targets on those policies. And here's some of the RCPs. The idea behind it and what the IPCC are working on at the moment through their CMEP6 model simulations, which will form the next IPCC report, the AOR6, which is currently under review by governments at the moment, or at least sections of it, is that you try and capture as many of the models with as many different outputs as possible, built in different ways by different teams, and really try and get a consensus for how likely these different scenarios are likely to happen into the future. And that provides decision-making capacity now. Okay, so let's take these global models and let's bring it back down to Ireland. If we look at Ireland on these global models and extract it, depending on what model we look at, it's quite grainy. So we get something like this. That's kind of the UK and Ireland. And that's great from a global model point of view because we can kind of capture what's happening from a global point of view, but that's not great from an Irish decision-making point of view. So what we can do is a trick called dynamical downscaling. Now what this involves is you take a postage stamp around your area of interest. And you take the global model, the output, and you feed it into the boundaries, you feed it into the edges, the red lines. And these models now, they're not just surface models with surface observations, but they're three-dimensional models. And by rerunning with different physics on a localized scale, what we're able to do is we're able to add an awful lot of extra value and extra detail to the climate simulations over a much smaller area. Now, you couldn't do this for the whole world because there simply isn't the computational power in order to run models at this resolution, at this level of accuracy for the whole world. But by stepping it down, by getting from the best global models that are out there and then downscaling it to finite projections over Ireland, we can add an awful lot of extra detail and in many cases some extra confidence intervals. And we can turn resolutions over Ireland that were looking like something like that from the global model into something more akin to what we see there. And that's a lot more useful for decision making, obviously built in with the current inherencies of the uncertainty envelope that's associated with any climate projections. But the question I'm always asked is, are they any good? Well, what we're looking at here on the left-hand side is real rainfall, so measured rainfall over Ireland over, give or take, a 30-year spell between 82 and 2014. So that's what fell. So that's the likes of John and others who observe us around the country, all our volunteer observers, literally hundreds of measured points over many, many years would give us an accurate picture of what happens there. And on the right-hand side, what we're looking at is what the climate model, the downscale climate model shows. And you can see striking similarities between the two, more rain on the west and the east and so forth. And that's the model downscale to 18 kilometers. Now, if we downscale that even further, bring it down to 6 kilometers, or downscale that even further, down 2 kilometers, see how strikingly good the climate model is at capturing reality. So it gives us an awful lot of confidence from an Irish perspective using these downscale techniques. And also we can see in the lights here, we can see that difference between what we saw earlier on, the twice the amount of rainfall falling in Flenshire than in Phoenix Park in Dublin. Okay, so you let the models run into the future. And what do the models show us from the future? And here's some of the reports, some of the results that are coming out from Paul Nolan's work funded by the EPA. So by mid-century, what we're expecting to see is that the mean temperatures will increase. and depending on scenario, increase between 1 and 1.6 degrees or so. We'd expect hot days to get even warmer. We're expecting cold nights to get warmer. We're expecting to see frost days decrease, the number of frost days decrease because it's warmer on average. And because of this warming, and assuming an adequate amount of moisture and water, we expect the growing season to also increase. Now, a few years ago, I was being interviewed by the national broadcaster in Slovenia. At the time, the Mediterranean were experiencing some serious droughts. And they were saying, how do you manage to convince Irish farmers of the dangers of climate change when they're looking at less frost days, longer growing seasons? And I pointed out, yes, there are opportunities. Climate change isn't necessarily all bad news. We need to look at all the eventual possibilities and look for opportunities within that. But as well as longer growing seasons and the less frost days, there's also comes a water management problem, potentially more droughts, heavier rainfall events, potentially more flooding. There's also, with the warmer temperatures, can bring different and more exotic pests and diseases. There can be also more extreme rainfall events and more extreme storms. So it's knowing about the future changes we can make decisions and try and adjust accordingly to balance them. It's not just about focusing just on part of it. We need to look at the whole picture. So continuing on there, we're looking at more heat waves on average during summer months. Heavy rainfall events, and this is really because a warmer atmosphere can carry more moisture. So if there's more moisture in the atmosphere, there's more potential for that rainfall to come. And what the climate models are showing is that they're expected to see heavier rainfall periods during winter months. And there's indications to show that although the number of storms passing over Ireland may decrease, those that are severe storms are likely to increase. And this is an important point. The warmer atmosphere can actually magnify and amplify severe storm events. And we're seeing this all over the world. Okay, so knowing all that from the past and the future, how do we know that now? And how can that actually help us now to make decisions? So I want to introduce you to the idea of climate services. And what climate services is taking all this knowledge, all this past and future knowledge, and actually trying to translate that into usable, actionable information that experts within the sectors can actually use to make real world decisions. So in our example here, the farmer is asking, do I need to plant drought resistant crops? Or maybe he's interested to know, well, what species of trees should I plant now so that it's still suitable by mid-century? The energy engineer is interested to know about a particular area, how much solar or wind energy would that area have had in the last few decades and how much is it likely to have going forward? Or with the pressure to build houses and new townlands with our increasing population, the water sector may be very interested to know is, well, will that river have enough water in it by mid-century in order for the new townland to be able to tap into it? And the way it works is you take all this meteorological information, you take all the sector-specific knowledge, and you blend the two of them together to co-produce climate services and products that are used then in order to help make these important real-world expensive decisions. And Ireland is moving towards more of a national framework towards climate services. We're moving towards more of a standardized set of climate projections that's government-backed and develop climate services on the back of these. So rather than have the agricultural industry and the water industry and the transport industry all going off trying to derive their own heavy rainfall index into the future, a climate service then, based on standardized climate projections, could develop these cross sectors, so everybody's working out to the same baseline. And that's the direction Ireland is moving. Now, I'll finish up with this, but just to finish, I want your hand with something. Why do me a favor and close your eyes? Okay, nobody can see you. Close your eyes and think about somewhere from 30 years ago. Maybe it's a house that you grew up in, an old farm, your parents' farm, an old piece of machinery, a bus stop, townland. And think of a severe storm, a Hurricane Charlie type or an Ophelia type of an event. And think of it passing through and think of the damage it caused, the slates off roofs, the downed trees, the power going out. Now, I want you to think of that exact same storm, nothing to do with climate change, that exact same storm, but happening now. Think of your surroundings now. Think of the damage that would be caused now. There's more population, there's more infrastructure. That tree that would have fallen in a field back 30 years ago may now fall through a Lewis control center. It may fall through a hospital or a road, a bridge that wasn't there 30 years ago. There's a potential for more damage purely because there's more infrastructure, because there's more people. Now, with your eyes closed, I want you to think of a scenario 30 years in the future. And I want you to think of that exact same storm, nothing to do with climate change, that same storm happening 30 years from now. A lot more electric cars, even more infrastructure, maybe your front door even operating off power that has gone out. Okay, now I want you to amplify that severe storm event because of global warming. Global warming has the power to magnify that. And I want you to think of all the extra damage that has caused by the more severe event caused by climate change. I want you to think of the thresholds that didn't actually happen last time now, but now have. Maybe that section of cliff face collapsed where it didn't under the normal storm. Maybe because the storm was more severe, that extra town got flooded or that extra river burst its banks. Maybe all those crops, because of the wind damage, all got wiped out because of that extra severe storm. Storms have always happened and storms will happen. But global warming can make storms more severe, and it's that extra damage is why all the governments all around the world are waking up. It's that extra damage that governments are coming together and putting policies in place to try and tackle climate change, because it's that extra damage we have the potential to do something about. Now, open your eyes. Climate science has given us the benefit of hindsight. Let's use it. I'll leave it there. Thanks for listening.
Keith, that was a really excellent, thought-provoking presentation with a dramatic ending, I must add. It's quite a stark reality that you present there, and really highlights the importance of having really good quality data and the work that John does in the weather stations and collecting that information. The projections that you're making, you've presented a number of different scenarios there, the SSRPs, I think you call them. Is there any of them more likely than the other in the slide that you presented?
So, in order for all modelers all around the world to be using the same set of assumptions or baselines, there are a set of emission profiles or pathways that the future worlds could take. So they're agreed and set in stone, and everybody works their models off those, simply so all different modeling groups can compare like for like. They cover a whole range. So they cover right up to business as usual approach, which is a trajectory over recently we've kind of been on, right the way down through to if we implement policies, right the way down to if we make huge changes, right the way down to net or effectively negative emissions. So they're all part of the realm of possibility, and really what Paris and the latest IPCC reports and so forth trying to bring global warming to keep it within 1.5 degrees and certainly below 2 degrees. They're all trying to tackle the pushes on a middle to lower trajectory path. So the fact of the matter is we don't know where we're going to be by mid-century and by the end of the century. What science does is science is able to give us a look into what those futures potentially look like. But really, it's to do with the global emission policies and how we actually stick to those, as well as new technologies and how all countries react to it will dictate which path we actually follow.
We've a really good question here, Keith. It's around that projecting into the future. The question reads here: if we could expand the data set on world temperature over millions or billions of years, would we not find that there is a larger natural cycle spaced by ice ages? Accepting that we do influence the speed of change, is it still not part of an overall natural cycle? This is a point that we see presented quite often. How can we be sure that this isn't part of some natural oscillation that's occurring in the climate?
Sure, yeah, no, we get a question a lot. So again, here we're looking at record sets that went back over the last 100, 150 years or so. If we start digging into paleoclimate records, we can start looking back right away through thousands of years into the past, ice ages and so forth. And we can see cycles, we can see the emission of volcanic activities and so forth as well. So we do see that base round change. Now, what the IPCC do, who are the produce these reports every 7 years or so, they put an awful lot of work into looking at all the paleoclimate, look at these background signals, look at these changes and fluctuations, the background signals, and they do what they can to capture that. But the signal they're seeing by the additional greenhouse gases, it's not replacing that, but it clearly sits on top of that background Mother Nature signal. Mm-hmm. So it's not saying that these cycles won't happen and there won't be future ice ages and so forth, many thousands of millions of years into the future and so forth. No one is replacing Mother Nature in any of this equation. But what we're focusing on the anthropogenic, the human influence piece that sits on top of these long-term cycles. Mm-hmm. And that's the bit that we have an awful lot of evidence on. And that's the bit we have the power to make changes on.
Mm-hmm. So we talked about hotter days, warmer nights, less frost days. So quite a lot of variation there in the climate and weather patterns. And I mean, you're teeing up our presentations for the next number of weeks very, very well, because we're going to be focusing on adaptation. Up to now, we've really focused on the mitigation options that have been available to us. What sort of work is happening there around the adaptation of how we operate as a society in a new climate scenario?
Yeah, so I guess I should just clarify and point out as well. So as we saw from the initial animation, the amount of weather systems Ireland gets as well, we're not necessarily painting a picture of a desert. Ireland's weather and climate is hugely variable. It's the average trend is what we're talking about there, the normal climate would expect. But in Ireland, we get huge variability about that, as we saw the big freeze in 2010 as well. So we should have spared that ability in mind. When it comes to adaptation then, so the government have been quite busy in the area of policy making ever since Paris Agreement in 2015. I mean, 2015 in Ireland, then we saw the Climate Act and the Low Carbon Development Act. That was followed by the mitigation plan and the adaptation framework in 2017. And part of the adaptation framework, there were 12 sectors that were all obliged to produce climate adaptation plans, agricultural sector being one of those. I believe we have a talk on that next week, if I'm right. So this was a big step forward for Ireland, and this was happening all across Europe as well, where the different sectors actually had to put together a solid plan in place and address what their sector is likely to see, the challenges it's likely to see into the coming decades, and how they're going to put plans in place to adapt around that now. And all those 12 sector reports were achieved. But in addition to that, all the local authorities also decided they'd be responsible to do this. And all local authorities also produced an adaptation report in around the same time. So Ireland has quite a comprehensive set of climate adaptation plans in place now across all the sectors. And really the attention is beginning to turn now from the plan to actually the implementation of these, and how can we actually implement some of the things we need to do in order to be a bit more climate prepared.
Thank you. Pádraig, some really interesting questions coming in there. Do you want to go through some of them for us?
Lots of questions, Mark. I think we've touched on some of them already, but one in particular, just spring is arriving a little bit earlier. You touched on it, Keith. You kind of mentioned it along the lines of temperature. You didn't really mention rainfall. How are the seasons being impacted, or how can farmers plan into the future, I suppose, around temperature, rainfall, spring, summer and autumn hitting when they should?
Yeah, so it's a very tricky one to plan year, season, month, week, in a sense that when we talk about climate, again, we're talking about 30-year trends. So we're talking about the average direction that things are moving. So just because it was a particularly wet, let's say, for example, last year, 2019, in February, it was particularly warm. This year in February, it was very, very wet. And then we had that very unseasonal dry spring, the droughts of spring from March, April, May then as well. So again, we get an awful lot of variation. It is quite difficult to plan. So there's no secret report I can give to say, do it this way or do it that way. I mean, farmers know more than anything else that they're, in many cases, held hostage to the weather. And it's really a case of keeping an eye on what's on the horizon. Now, the good news is that there are more advances in greater outlooks from the weather forecasts. So up to now, the skill in the forecast, ECMWF be one of the statistically best weather models in the world, and Eireann are a member of those, and we often use those for our long-range forecasts. They've scaled out to about 10 days under certain circumstances, certainly with Ireland, out towards 5-7 days they can be skilled towards. But we're now seeing greater skill in monthly forecasts now as well. So having an indication, is the month ahead going to be wetter than normal or colder than normal, can provide some indication for farmers' decision making. And also what we're beginning to see come online internally at the moment, we haven't released them yet because we're evaluating them, but we're also evaluating seasonal forecasts for Ireland. So an outlook for the next 3 months ahead. And we're using the best models that are available for the world in order to evaluate, in order to do this. So I guess my best advice was always pay attention to the forecast. We start issuing more monthly forecasts as we go into the future, and soon in the near future we'll also start issuing seasonal forecasts. And not to get people's hopes up, sometimes seasonal forecasts, just the nature of them and where we are in the world, sometimes it's kind of an equal chance of wetter than normal, around normal, or drier than normal. But sometimes the models do show a signal of a hotter period than normal, or a colder period than normal, and so forth. So my best advice really is keep an eye on the Eireann forecasts, and as the latest science and credible information for Ireland starts to become available, we'll make sure that the Irish public have access to that.
Okay, we have another couple of questions here, Keith. Agriculture appears to be taking more than its fair share of the blame for climate change. Agriculture to date has followed scientific advice and got us into this mess. Can we trust the scientists to then resolve the damage? And just to kind of put that together with another one, which with the greenhouse gas growth rate into the atmosphere, which of the kind of greenhouse gases are the most worrying? Is it CO2, methane, or nitrous oxide in your view? So two together there.
Yeah, okay. So yeah, it's a difficult one, and all sectors have their own opinion, not just in Ireland, but globally in this, in the sense that it's the global emissions that are changing the energy balance for the globe, and then we see all the knock-on effects from climate change from that. So Ireland, relative to a lot of our European neighbours, we'd have quite a large agricultural sector. So obviously we'll have more emissions based on someone who has a smaller sector. So it's really not an easy one to solve. And I certainly don't have the answer to it. I mean, the emissions is not the area that Eireann work in. Eireann deals very much with the weather and the climate itself. But I understand and appreciate the question and the pain behind it. It's not an easy answer. The Department of Climate Action, under the government's All Action Plan, have set targets that Ireland will need to try and meet in order to be compliant with the Paris Agreement and others. Exactly how that's done, I understand it still remains to be decided. But it's not going to be an easy one to fix across all industries.
An easier one that you might find to answer then. You showed Ireland on the same latitude as Canada. And obviously we look quite green in that image, and they looked quite pale and white and covered in snow. And you kind of suggest that the Gulf Stream was what was keeping us in the environment that we're in. Is there any risk to that changing in the future, or how could that look? You didn't mention it in the kind of future projections.
No, so there's a lot of work happening out of Maynooth at the moment on that, where they're actually looking at the Gulf Stream and the strength of the Gulf Stream. So there is, I mean, there are a lot of measurements happening from that at the moment, and they're beginning to find a hint that there may be a slight change to that. Now, there's no fear at the moment, at least among the ocean scientists, that it's going to stop overnight, like the Hollywood movie was in 2012 or something like that, where the premise behind that was that the Gulf Stream effectively stopped very, very quickly. There's no fear that the Gulf Stream is going to stop quickly, but there is initial suggestions that there may be a slowing or a changing of the Gulf Stream. And there's a project underway at the moment to try and keep an eye on that. Obviously, as an awful lot of the ice sheet begins to melt and comes in, you're changing the salinity of the water in the North Atlantic. So that can affect the whole environment of this conveyor belt system. But there's no immediate concerns that over the next number of generations that there's going to be a sudden stop in that. But there may very well be slight changes to that. Touching off sorry, Mark, wait.
We're a few comments coming through about, Ireland. We're a major, a lot of our agricultural produce is exported, so we're quite reliant on global markets. We have a question here in relation to the impact of the temperature change in other grain producing parts of the world, for example, the Midwest and USA, Russia, and so on. And the question is, will these areas also have lower rainfall, and with that higher temperatures and evaporation rates, how big an impact will the future climate projections have on these major food producing areas, and the impact on yields? Has there any work been done on that? Of course, that has implications for Ireland if we are, from an opportunistic point of view.
Yeah, no, very much so. And I guess, again, this is something that the Mediterranean countries are kind of interested in as well, is if they're more penalized, if you like, by the more droughts. I mean, that creates opportunities to areas that can grow more produce. I'm not overly familiar with all the areas that's spoken about there, but if I can speak in general terms, the warmer atmosphere has potential to absorb greater moisture. And with a greater moisture in the atmosphere, you can get an awful lot of extra heavy rainfall events, and it can change the dynamics of systems. So that can lead to a change in weather patterns. It can lead to heavier rainfall events and more flooding. But also the way that the atmosphere works is that it can also lead to more stable and prolonged periods of dry spells. And we begin to see that in a number of places around the world. Particularly, it often makes the news, not necessarily because it's drought, but often it makes the news because a fire ignited, and we see forest fires. We would have seen them in Australia there recently as well. So these are all visual effects of the droughts that are happening, partly as a consequence of changing patterns that are happening globally. So globally, people are seeing change in weather patterns. Whether those weather patterns are bad for your particular region of interest, or potentially good for your particular region of interest, it may bring more rain to an area that ordinarily might struggle for rain as well. It would really depend on where you are in the world. And again, you have to bear in mind the fact that there's an awful lot of fluctuations and variabilities in certain parts of the planet as well. We see it particularly in Ireland, where you get a huge variability either side. So even though the trend is for drier periods or wetter periods or warmer periods, that doesn't necessarily mean you're going to get that year in, year out. So change is on the cards. Whether you could directly penalize some areas and others, you'll have to specifically look at those. I know from the Mediterranean are very worried. A lot of the vineyards in the Mediterranean are already looking at buying up land further north that isn't necessarily great for growing vines at the moment, but by mid-century would be the right temperate climates in order to keep these vines alive while areas are green and so forth. So it's really very regionalized, and you have to be quite an expert in the particular region to have a bit more knowledge on it.
We have a comment here in relation to the overall communications of climate change to the wider public. A point being made here that maybe as part of a broader public awareness and engagement, do you think that maybe extreme weather events, when they're being presented on television, that climate change should be linked more closely to those, or indeed listing the atmospheric CO2 parts per million as part of the forecasts, just in a bit to create that broader awareness amongst people? I think that's always a risk when we're hearing about something the whole time. We become desensitized from the issues, which I'm sure is a major issue for when communicating the severity and the importance of climate change.
Yeah, no, this is a really good one actually, and it's something we're actually looking into at the moment. So we know we need to do a better job of communicating climate. In fact, the Oireachtas last year, Eireann and RTE went in together, and the whole topic of climate communication was discussed in some depth, in some detail. So since then, we've been really looking at ways to better communicate the climate message. We've started doing that through a number of different ways. Even internally within Eireann ourselves, we're trying to create some internal videos and so forth, educational pieces around the area. Obviously, we have that presence on TV as well. That's an RTE contract. It's an RTE decision that Eireann provide the forecasts for that. But certainly also in conversations with RTE, looking at ways to how best to improve and increase that climate communication message. It's done differently in different places. I mean, again, if you just have the CO2 level the whole time, CO2 is quite a seasonal, has a seasonal signal to it. And if you look over many decades, you see this really consistent increase in CO2 levels. And it's a very powerful graph. In fact, it's one of the most important graphs to ever come out of climate science from a policymaking point of view. That famous graph from Mauna Loa in Hawaii, the observatory there, where a guy, Charles Keeling, back in 1958 started measuring CO2 out in the middle of the Pacific, and kept on doing it to the highest standards right up to 2005 when he passed away. And then the program got taken over by his son Ralph, and that program continues to today. And you see this really consistent, powerful increase in CO2, and you can link that to correlations in increased global warming. That type of stuff is really powerful. But if you're going to be putting the CO2 value of the last week or the day every night on the TV, on the news, that's just a number. You're missing out on the graph. And if you put the whole graph in there then as well, people get bored looking at the same graph, and it may be tiny. You can almost predict where it's going to go. So it's not as simple as just reporting those news. So we're very conscious of this, and it's something we're actually looking into. But it's important to get it right, to get the message right as we get it across.
Keith, you mentioned just putting the CO2 value on the news each night. Just in relation to what's happened with COVID-19 and the reduced activity in the skies and on the roads and so on, are you seeing any trends in relation to that, or any comments around that?
Yeah, so one of the big things we noticed during COVID-19 was there was a lack of observations, actually. So when we run weather models and climate models, they're three-dimensional models. So they're not just weather stations at ground level, but we also need an awful lot of vertical profile information up through the atmosphere as well. And we get them through a whole host of different means, some satellite observations, but we get an awful lot of the actual in situ measurements from airplanes, from instruments that are attached to airplane wings. And as many thousands of airplanes fly all around the world, we get a three-dimensional snapshot, and you can create a snapshot of the world, and that's what initiates weather forecast models and ultimately climate models. Now, what we saw during COVID-19 was that obviously with the lack of air traffic, we lost an awful lot of those vertical profile information. So we lost an awful lot of measurements that would be used to help seed our forecast models. So what we did was we actually launched weather balloons from Flemish Observatory down in Kerry, Ireland. It's one of the most important locations actually in Europe, because if you think about it, the wind is coming in from the west in Europe. So Kerry is one of the first places to actually sample those air masses coming into Ireland. So twice a day we launch weather balloons from there. And during the COVID, with the lack of airplane measurements then as well, we started launching twice in them. We started launching 4 weather balloons a day. And many other countries around Europe did the same as well. And that way we had more vertical information, and that was able to help increase the forecast skill, which was very important because the aviation and all the important flights and keeping the air bridges open all need detailed weather forecast information as well. And I guess it's one of the real important things when it comes to, a lot of people don't see behind the scenes. A lot of people see the forecast, so they see the climate projections. They don't see the engine that goes behind this. And what powers the Lego blocks that powers all the projections and all the weather forecasts really are the observations. Because even if you take weather balloons, for example, what happens twice a day, every day, at midday and midnight, is all around the world. Everyone launches weather balloons at exactly the same time. And those weather balloons spend about an hour and a half going up through the atmosphere, gathering information and sending it back. And what that does is that creates this three-dimensional snapshot of the planet. And that gets ingested then into everyone's forecast model. So it doesn't matter if you're fighting with your neighbor or there's political reasons why you're at economic war. Everybody still does this act of unison from a weather measurement point of view in order for the greater benefit of everybody else. And I guess that's probably why the World Meteorological Organization sits inside the United Nations, because weather and climate really do hold no boundaries.
We have some.
Sorry, go ahead, Mark.
Sorry, we have a fairly technical question here, Keith, which I don't intend going into the nitty-gritty of it, but the question relates to the CO2 estimates by the IPCC in 2013, and asking about the work that Ray Bates did in 2016 to show that the CO2 has only about 1/3 of the global warming potential that had been stated by the IPCC. Maybe could you just make a general comment on that for us, Keith, about the different figures that are being used by different organizations?
Yeah, so I'm not overly familiar with the exact figures that are used, but the IPCC, they try and do a thorough job of being transparent in using the general background consensus, so that they average out what many different models say, what many different scientists say, and they're quite transparent on how they actually work. That's not to say that the average answer they come out with would agree with what everybody else says, and there may be extra science in there that will may inform the next iteration of IPCC. But at any one step, you kind of have to take a stop and actually have a look then to see, use that information to make important decisions, and then take the next set of science that comes out of that. I'm not overly familiar with the exact argument on Ray Bates, but I do know Ray Bates is extremely well, an extremely knowledgeable person in this area. I guarantee he's forgotten more about climate scientists than I've ever known. Actually, a former professor of mine as well. So if he speaks, it certainly needs to be listened to. But not just him, all scientists from all countries need to be listened to. We shouldn't be following or going down the road of a mantra just because it's popular. It's very important that science backs up all our decision-making process. And science is always evolving, and the IPCC are always evolving. So if enough publications are being made that are backed by real science and are gathering enough momentum, then I'm confident that the true science will find its way to the top.
I think we've got time for one last question, Porrick.
I guess I was going to ask for a bit of a summary. What core ag can expect into the future? You mentioned some guys in southern hemisphere, I guess, buying up vineyards further north and so on. Will Irish farmers be looking at trends like that? Or look, I guess in summary, you were talking about warmer temperature, more rain, or more intense rain. So just a little bit of a summary for farmers looking on, what can they expect?
Yeah, so personally, I mean, there's a lot of politics, and there's a lot of missions and stuff that all needs to be sorted out, and I understand the sensitivity around all of these issues. But my view from a climate point of view, looking at the agricultural industry and talking to a lot of international colleagues around Europe as well, is that there's a lot of people around Europe looking towards northwest of Europe and quite jealous of it. They see an awful lot of opportunity in the coming decades. Like I say, those longer growing seasons, those potentially more favorable conditions. Okay, there may be a bit more of a water management issue with regards to trying to store water maybe in the winter and using it more during the summer, or irrigation and so forth. But the net amount of water will be similar to the net amount of water we have now. It's just a case about using that. Whereas when you look to other parts of the Mediterranean, they're in an awful lot of trouble, and they're predicted to get even worse going forward into the future. So I think my personal view is that for agricultural industry in Ireland, that there will be changes to climate. It's important that we adapt to those changes, but I think there's an awful lot of opportunity there as well. And I think northwest of Europe, in particular Ireland, can be really position ourselves to be in a very healthy place.
I think that's a good note to end our session here today, Keith. On behalf of Teagasc, I want to thank you for your time today and really excellent presentation. And I suppose on behalf of the agricultural community, I just want to share our gratitude for the work that Eireann does and the important role that Eireann has to play in everyday farm life. And I live here in the west of Ireland, so we heavily rely on the weather forecasts here, but just a general note of thanks to you and your colleagues for all of the work that you do. Thanks to Pádraig for helping out with the questions today, and also to Andy Boland, Yvonne Maher and Pat Murphy, and to all of our partners, supporting partners in this series. Just a special thanks to everybody. Just to let you know that next week we are going to be taking a closer look at the adaptation of Ireland's society to climate change. So Maria Talbot from the Department of Agriculture, Food and the Marine will be speaking about adapting to the impacts of climate change in the agriculture sector. And then Teagasc's Michael O'Donovan will be talking about grass growth variability and how we can improve that over time. And also you can see a number of other presentations that will be delivered during the rest of August, ranging from carbon sequestration to energy. So we do hope that you can join us for those webinars. So with that, I'd like to thank you for joining us. We're moving into summertime, so we do appreciate you taking the time to join us. And if you are away from your desk, you can still view the Teagasc Signpost webinars on your mobile. If you download the Zoom app, you can view the webinars at any stage. And also find a reminder that you can now sign up to Teagasc Connected Digital for free if you go to teagasc.ie/connected and click on Join Now. You can get a range of benefits, including a monthly newsletter, which gives you updates on webinars and new events and training opportunities available from Teagasc. So with that, thanks again, Keith and Pádraig, and we will look forward to seeing you all again next week. Thanks very much.